Okay, we're following up on Google search today. Where we left off last time was talking about the rise and decline of many search engines during the great search engine war of the 90s. At the end, the only one with any real impact to survive was Google. Bing still persists. We'll talk about that in a minute. But the short reason why Google prospered, number one, it had a simple interface. It was easy to use. You showed up and used it. It wasn't packed with ads like some of the other ones. And over time, Google started trying to do a better job of delivering the search results that users wanted. Other operations basically focused on bringing exact pages containing the exact text, but weren't doing a more sophisticated job of trying to analyze the meanings behind those words. Okay. So Google wants to give high quality search results. That means the results that are the best, right, which means that most users are interested in seeing, those are going to appear higher in the search listings. And that will encourage use and reuse, right? People say, oh, Google gives me good search results. I find what I'm looking for quickly. I don't have to sort through a bunch of pages to find what I want. That's great. I'll come back and use Google again. Now, many of the competitors of Google use something called paid inclusion. Okay, so paid inclusion basically means the platform will let advertisers pay to have their site ranked higher in the listings. So the distinction here, okay, so let's mark this because it's not as simple as it sounds that just paid inclusion is bad. So there's a little bit more to it than that. Okay, so paid inclusion simply means letting sites pay to be ranked higher in search listings. Okay. So what's the downside of this? Well, the downside is relevance will be lower, probably. We'll get to that in a second, right? Because the search engine isn't actually evaluating the sites, right? So ideally, track stuff for attributes like popularity or, established, whether the site's established or contextual factors, okay? Any of those things, no, they're not really going to show up. It's just if the site is willing to pay more, it can get bumped to the top of the listings. Okay, the good side of this, though, the upside, if your search engine is not especially sophisticated for filtering out the garbagey sites, then paid inclusion makes more sense as a filtering mechanism. That is, only sites willing to pay to be listed, well, rather, any sites willing to pay to be listed are probably legitimate commercial sites. So, to a point, paid inclusion makes sense, but if you have a good sorting algorithm, filtering algorithm for saying, this site is kind of garbagey, these other ones aren't, then paid inclusion will just aggravate customers, right? So unless customers are specifically looking to buy something, advertisements are annoying, right? So people don't like having their search results cluttered with advertisements, and they do make the searches more tedious. You have to skip over all the ads and take longer to load. Okay, so all those are factors. So because Google, right, the core of Google service is free search. Okay, in some cases, it makes sense to show ads along with the search results but always wants to keep its search results pure, right? That's the technical term, pure. That means no one can pay Google to get their site listed higher in normal search results, okay? You can pay to get a better ad position, though. Okay, so when Google runs the ads along with the search results, yeah, you can pay extra for that. Okay, so the core thing, Google gives the best search results, which keeps its user base stable, which provides the traffic flow to all of Google's many other services, most of which are profitable. Okay, so search as itself, search is free. Google's not making money off of that, but because the search results are good, advertisers know that a lot of customers are going to come use Google search results so they can advertise along with it. Same thing for Google's many other features. Now, stuff like G Suite, of course, is offered free, so that's different, but yeah, Google's making a lot of money off a lot of things, and the core to that is simply having a lot of traffic through search in the first place. Okay. Now, as I said, paid inclusion is generally avoided by Google, but there are some cases in what used to be called Google Marketplace and now Google Shopping. You can advertise to have your listings placed higher to get a better position for them. So in regular Google search results, if you go to www.google.com and run a search, those search results are pure. Not necessarily the case for any of Google's other operations. Okay, so how does Google do the search results? Well, the core model is something called PageRank. PageRank was an early algorithm where Google recognized that a lot of traffic went to bigger, more established sites that had more pages. And Google wanted to come up with an algorithm that basically mimicked that sort of outcome. So what they did is they came up with a probability function that would show that a random web user would arrive at a particular page on the internet. So because important sites tend to have more pages and tend to be linked to more other sites, there's more ways to get to those bigger sites. So unfortunately, this PageRank algorithm is basically correlation, not causation. So it worked in the sense that, yes, it did deliver basically what people wanted, but because it wasn't causal, there wasn't a causal relationship there, it was able to be exploited. So initially, pages with a high page rank, they would rank higher in the search listings. And like I said, they would typically be from bigger sites, more established sites, sites that were linked to more places. But the downside, within a few years, there was a huge wave of other sites that were trying to manipulate those rankings, right? So part one of that, if you wanted to create a garbagey site, basically you could pack it with a bunch of links, and you could make a site that had a whole bunch of pages on it, and then that would tend to automatically rank high in Google search listings. So this was a real problem. The other thing is Google's PageRank did tend to excessively favor older and more established sites. So even if some newer content was a much better match for the search terms that were entered, because of PageRank, anytime that there was a big site, it would tend to crowd out all of the other possibilities. So Google needed to do a better job of delivering good search results if they wanted to keep getting business. All right, so this concept of making basically a junky page that's designed to just capture traffic and hope that users click on ads is what's called a spam blog, or sometimes a splog. One second, I'm going to pause here. My daughter apparently needs something from me. Hi, sweetie, what's happening? Okay, well, you're making me a little nervous when you're running around in the room. I'm a little bit concerned. Okay, I gotta do my lecture, sweetie. Okay. Okay, I gotta do my lecture, sweetie. All right. Well, we have kids sometimes. What can you say? Okay. So spam blogs, what they would essentially do, they would pack the site with popular search terms to draw traffic. So it would be a big site that would have a lot of links and a lot of pages on the site. One second. Vivi, you got to get out of here, sweetie, because you're making noise in the background. It's hard for me to talk. Sorry, sweetie. Okay, I'll see you afterward. All right. So here we are in the age of COVID. Okay. So they'd pack their sites with lots of popular search terms, try to draw traffic. Another trick they might do is use very large pages so that when you went to the site, you'd only see a little corner of it that actually had some content in it, but the whole rest of the page would be, massive, like 5,000 by 5,000 pixels and just packed with a bunch of text. Or sometimes they'd have images or ads that they'd hide words behind. And in general, lots and lots and lots and lots and lots of ads. Okay. So this was a problem. Now, spam blogs, they do still exist, but they're harder to find. The basic trick for this, for how they would work, remember, under the old PageRank algorithm, a site ranks highly if, number one, it has a lot of pages, and number two, it has many links to other pages, right? Or more correctly, many other pages link to it. So the easiest exploit, build a large site with many pages that link to each other. And then step two, build a network of junky sites that all link to each other. Okay, so then they'll rank high in search, even though they don't have any real content there, even though they lack interesting content, they'll rank high in PageRank and thus appear in search. Okay, and hopefully, from their perspective, some users will accidentally click on an ad and give the site some cash. Okay, that's what they were trying to do. So Google needed to fix this. Google needed a way to detect spam blogs and filter them out of the search results. Okay, and ideally, a fully automated technique. Okay, so that's what Google needed to do. In order to deliver good search results that weren't crowded with all of these spam blog entries, Google needed to filter them out. So what happens next? Well, first of all, you can think about the sort of things that are going to appear on a spam blog, right? Google can recognize that. So things like recognized by, number one, large quantities of ads, okay? Number two, large quantities of popular search terms and little else, okay? Making no grammatical sense, right? So it's basically like a long dictionary listing. So those were a couple things. Number three, very low repeat visits and frequent what are called bounces, where people immediately leave the site. Okay, so factors like that, Google basically was able to make a long list of all the sites that, yeah, these are pretty junky, and once Google identifies a site as spammy, it simply doesn't index the page, so it never shows up. It never shows in search results. Okay, that is the essential way Google did it. Now, of course, there's also a factor people could report these spam blogs back in the day, but you hardly ever see them anymore. So up until about 10 years ago, you would see lots of spam blogs in Google search results. But then Google said, yeah, this is a big problem. We gotta fix this. So most of those spam blogs, once they weren't able to show up in the regular search results anymore, it wasn't worth their time and trouble to maintain them. So they had to come up with some kind of content that people found valuable. So what we saw is that this sort of stuff exists on a spectrum. Okay. So over here, we can list high quality content. Okay. Whatever that is. Okay. So we're not going to judge what's high quality and what isn't. We're going to say if people like it and keep coming back for it, then that's high quality. Okay. So then we have over here, you know, total junk and basically no returns. So nobody who sees one of these super junky pages comes back to look at it. It's not what they're looking for. Somewhere in the middle here, you know, clickbait. Junky, but maybe fun. Okay, so, you know, your typical clickbait article would be something like, here are 12 signs your girlfriend is about to dump you. You won't believe number 8. Or 25 places to visit before you die. Or the 100 greatest bands of all time, that sort of thing, right? It's clickbait. It's usually junky. It might be entertaining. It's not usually terribly informative, but whatever. Not everything in life has to be a, you know, brilliant classical work of art. So these guys, right? Filtered out. Okay. Over here, we'll do this. We'll do yellow for this. And we'll say questionable value, but not Google's call. Visit if you like. Okay. And then this stuff over here, high quality content. Yeah, that stuff people keep coming back to. Now, if you were going to go with the assumption that, you know, you can have metrics for what's high quality. Okay, so this sort of stuff gets priority in listings. Okay, and one of the things Google looks at to determine this, determined by factors like repeat visits and frequency of clicks in search results. So if users often click on a particular site, and if Google has the analytics data where they can see that users are keeping on coming back, they're going to say, oh, this is fairly high quality content. We're going to bump this up higher in the listings. If there's other stuff that people aren't clicking on that much, or when they do click on it, they don't tend to come back, then Google says, yeah, okay, maybe this isn't as good. This isn't quite what people are looking for. And then the other stuff that's total junk that nobody stays on the site and people just go away immediately afterward, yeah, Google's going to largely filter that out from the search results entirely. Okay, so that's the basic formula there. So essentially, Google fought back more sophisticated site analysis and to an extent relying on user feedback. So users could always report, hey, this isn't a real page. This is just some junk packed with random search terms. Okay. Now, Google has to continually monitor web pages in order to return current and high-quality search results. Many pages inherently have dynamic content. For example, if you have some news site about whatever's breaking news, well, breaking news is going to change from 1 hour to the next. Other pages, even though the data is static, right, it doesn't change while it's on the page, or it's not something that's changeable, well, people can always go in there and edit the documents, make corrections or updates, whatever. So, for example, something like Wikipedia pages, right? Wikipedia pages periodically change through the editing process. Some are more stable than others, but they're all potentially changeable. And of course, on any site, new pages are often created and or deleted. So Amazon is a good example there. So they have literally 3 billion or so products worldwide, last I checked. And obviously that means, you know, if you figure they've been around for, I don't know, 10,000 days or so, it's getting close to that. That's still a whole lot of pages created every day. So, yeah. Anyway, ultimately, Google has to store a fairly current replica of what's called the surface internet. So all of the pages and all the content that's available to just anybody. So not behind a paywall, not behind some kind of password protection or enterprise security boundary. So even 10 years ago, Google was checking literally 1 trillion URLs several times a day. And that was 10 years ago when there's a lot fewer sites than there are now. So this is definitely a big data problem. Going out there, managing the process of visiting 1 trillion or more pages per day, figuring out which ones are updated, which ones aren't, integrating those updates into your database so that your search engine can deliver current search results. This is a whole big problem. Okay, and the fact that Google is, again, able to do it reasonably well was core to its success. Okay. So on Google's side, gathering and using all this data that supports people's searches, that has 3 stages. The first one is crawling. So in crawling, Google sends out software agents, so basically runs little automated browser programs to go out to pages all over the internet and pull their web data and see what links they have and go on to next pages. So that's one thing. Second thing is indexing. So in indexing, once Google has this data, it has to decide what to do with it. Basically, it has to store it into a giant internet scale database so that it's available for people to find things. And then the last part, retrieval. So anytime somebody runs a search query in Google, Google has to dig through this index to some extent and find what pages match it the best. Now, of course, if people repeatedly do a search, Google doesn't have to do the entire search from scratch. It can cache those popular search results. So for example, if there's some breaking news about, I don't know, a tornado in Chicago, and there's a lot of people searching on that, well, Google's going to cache the popular search results periodically. So it doesn't have to do that from scratch and use its system's capabilities to do that. Okay, I have a couple links here, but they're very basic. They're like a paragraph each, so they don't really talk about it a whole lot, but it's a place to start. Okay. So crawling. Google has these software agents. They visit pages, they gather their links and other data. These agents are called crawlers or spiders. And after a page is visited, any pages that page links to also get visited. So the eventual result, eventually Google builds a graph of the entire conventional internet, right? Everything that's not in what's called the dark web. Okay. So let me give an example of how this works. So suppose there is a site, right? Let's do that in black. Here's one site, here's another site, here's another site. Okay. And on this page, this site, there's one page that links to a few others. And on this site, there's one page that links to a few others. And on this site, there's one page that links to a few others. And there's going to be some cross links between them. Okay, so this site, Okay, this site goes to these ones. This site goes to these ones. Okay. Now, at any given point, Google might say, launch a spider to one of these pages, right? A Google bot. So suppose it goes here first. I'm going to put a 1 here. Since all of these pages are linked, Google's first going to grab this page. Okay. Not garb. Going to grab this page. And then it's going to, well, that's not what I wanted to do. Follow links to more pages. Okay, so if this is like an index page on the site, then one at a time it can go through all of these. Okay, now maybe this page over here is linked somehow. Okay, so there's a link on page 5, link from number 5, and Google says, oh, we haven't seen this site. Maybe this is a brand new site that was just created that day. So the spider says, okay, I found a link there. Sure, I'm going to go to do this one. Okay, it's going to go there. This page maybe only links to this one. Okay, it could travel back through that link, but it's already visited this page, so it won't. But it sees, oh, there's these 2 new pages, right? We'll do 8 and 9. Now it might be, suppose that Google has already searched these pages. Well, if this page is linked, if 9 is linked to 10, if 9 is linked to 10, Google won't immediately scan 10 because it already has. Okay. That's the essential process. So Google sends out these spiders to different websites. Once it reaches a page, it's going to grab that data from that page, send it to Google's indexing system. It's going to check out all the links from that page, and then again, it'll eventually perhaps go to other sites. Now, of course, all of these pages could as well link to other pages that maybe the spiders are going to have to search. Okay, but yeah, anytime Google finds a page that it's already searched, it's going to, it's already indexed, it's going to ignore that for the time being. Okay, so that's how that crawling aspect of it works. Anyway, periodically Google will also schedule repeat visits to check for page changes. Now, how often a particular page gets rechecked depends on a lot of factors. First one, popularity. If a page is very, very popular, then Google says, well, we're going to get more bang for our buck for the effort of actually scanning that page and seeing if anything has changed, right? Because if it's a very popular page, that's going to show up in a lot of search results, and sure, we want that to be up to date. Second thing is reliability. If a page is frequently unavailable, Google is going to think, this probably isn't an entirely legitimate page. This is some kind of garbagey page that, if the people who run it don't even care enough to make it regularly available, yeah, we're not gonna really bust ourselves trying to get this page indexed repeatedly. The last one is the update frequency. So the more often a page gets changed and updated, the more often Google's going to send a bot out to check it, because a page that gets frequently updated needs to be frequently checked in order to deliver current information through search. But if Google sends a bot out every day for a week, and every time it goes out there says, nope, nothing's changed on this page, then Google's going to pretty much ignore that, right? It's going to say, okay, maybe the next time we check, it'll be like a week or two later, because this is a page we don't seem to need to check every day. But if Google comes back one day and finds that something has changed, then that can make Google check at shorter intervals again for a while, at least until it figures out that that was a one-off change and not something that's going to likely repeat frequently. Okay. Now, a Google bot is basically a browser, again, an automated browser program, visits pages, copies their content. It's a pretty simple program. It's not much different from any browser that you or I would run on our machines, and it doesn't do any processing besides reading the content and following links. Any content that it grabs from a page gets sent to Google's indexing system, and it is not guaranteed that all content will be transferred that way. For example, sites can include a robots.txt file that specifies any content that spiders should ignore. So, for example, imagine you have some news article. Okay, so some news article about something. We don't care what. Now, there's the article itself, and that, of course, should be considered for the indexing process. Okay, but below that, you're probably going to have some space for comments, right? And those probably should not be considered for the indexing process, right? Because there are going to be people saying stuff like, Joe, he's going to say, haha, first. And then Susie is going to say, like, you suck, Joe. And then Joe's going to say, your mama. And Susie's going to say, I am your mama. Okay, and then things just go wrong from there. Anyway, so these kind of comments, right, that's not really what people are searching for the page for. People are searching based on the article. So somewhere on the site, not necessarily on the page, somewhere on the site there's going to be a robots.txt file that says, yeah, stuff that's in these comments blocks, don't include them as part of your search, because that's not really part of the page content. That's just some extra potentially garbagey stuff that random people show up and add. Okay, and the reason why people do this, I should add that. I'll do this in green because green is the color of money. Reason why sites want to exclude certain content from indexing. Okay. If your site shows up on various unintended search terms, it may lower Google's perception of the site's quality. Okay, that's essentially the problem, because people who see the search result will be less likely to click it. Okay, so in order to help maintain their search listings ranking, they only want to be shown along with relevant search terms. Okay, so the people who see them will be more likely to click on it. Okay, that's the reason why sites might actually go to the trouble of setting up this kind of robots.txt file. Okay. Other stuff, what's hidden? Well, we have the deep web and the dark web. Okay, so we're going to draw a picture here to split all this. I gotta get around here. Okay. So the internet as a whole is built up of a few different areas. So number one, you have, I'm going to draw a split here with blue, light blue. Up here you have the surface internet. Okay, everything visible to Google bots. Okay, so not behind security or paywall or encryption. Okay, just everything that's just ordinarily visible. Now below that, we have what's called, I'll do pink, I guess, the deep web. Okay, and on the deep web, content that is hidden. Okay, as a fraction of the deep web, we have this part known as, do it in red here, the dark web. Ooh, that doesn't show up. So let's do, what do you think, green, orange? Yeah, that'll work, I guess. Then we have the dark web. Okay, anonymized and often illegal or profoundly immoral content. Okay, so these are the three breakdowns of it. So the surface internet, everything that's visible; the deep web, content that is hidden, and this is often, you know, often legitimate, like your email account, right? You don't want anybody to just see that, or bank accounts, etc. Anything that's password protected, behind a paywall, whatever. But again, the dark web is part of the deep web. So what I should do is cut that out. Whoop. I guess that'll work. So I'm going to fill stuff in just to emphasize that this is part of it. And then, there we go. Okay, so the dark web is part of the deep web. It's not a whole separate thing. Okay, so the deep web, again, all this stuff includes content hidden behind in robot.txt files. The dark web is something that's designed for anonymous usage. It is a small part of the deep web and is often associated with criminal activity like Silk Road. So for those of you who haven't heard of it, the Silk Road was a way that you could buy drugs through the internet, right? Illegal drugs, not purely medicinal ones. So All right, it brings up a an obvious thing. Suppose you're a drug dealer and you want to sell your drugs through the internet. Well, you can't just drop them in a mailbox, and you can't just set up an ordinary website that says, buy our designer chemicals here. How do you get to people? Well, that's the real question. In fact, that's how the FBI was able to eventually track down the guy who was in charge of this. Is that they sat around and they think, well, you have this problem, right? You have this entirely anonymous hidden site. How are people even going to find out about it? Well, you'd have to do some advertising, right? You'd have to show up on some message boards, tell people about it, and say, hey, here's some place where you guys ought to go. So that's what they figured probably happened. So they went around, they looked for the earliest references to the Silk Road that they could find on various message boards. And they figured, well, even if we don't get the guy who created the site, we'll get somebody who's close to him, who knows him, whatever. Maybe he'll tell us some stuff. In fact, as it turned out, yeah, they did find the guy who set up the site in the first place. And now I think he's serving like 40 to life. So, yeah, because a few of the drugs they sold resulted in some deaths. And of course, he was responsible for that. So that's part of it. The two basic tools for using the dark web. Number one, what's called a Tor browser. So Tor is anonymous internet access. It uses what's called onion routing. So every time you go from one site to another, it's going to anonymize your path that you arrived from. So basically, it makes it very difficult to track what site visitors came from where. And so you can kind of drift around the internet without really exposing yourself. Now, it's not entirely perfect. There's various ways where this stuff can get broken down, but it's a lot of work. So basically, if you have a Tor browser and you're on the dark web for some reason, unless you're doing some really bad stuff, the government's probably not going to put a lot of effort into chasing you. They're not going to go after the small fish that, although you never know, you could still get caught. Second thing, I2P. So I2P is anonymous website hosting. So just like the users of the dark web want to be anonymous, well, the people that set up websites on there also want to remain anonymous. And it's the same kind of principle that any data that arrives from a source is going to go through multiple rounds of encryption. So it's very difficult to, even if you visit the site, very difficult to see where it came from. Now, having said that, there was one case I remember like a year or two ago. There was some kind of child pornography ring out of South Korea. And the thing was, even though their site was encrypted, right, it was hosted on this I2P, one of the pages basically just listed the dude's IP address, right, the location of where the server was. And so their IP addresses are basically set up kind of like phone numbers. There's a geographical relationship in how the numbers are assigned. So they fairly quickly located this guy's house and they said, oh, this is where he is, knocked on the door, they got him, they busted him, and busted a few hundred people worldwide. So again, if you're doing some bad stuff, yeah, you can eventually get caught, but there's people out there using it. Other interesting fact about the dark web, this Tor browsers in particular, they were designed for United States espionage agents. So spies, if they're operating in foreign countries where they don't know that they have an entirely secure internet connection, right, that somebody could be listening in, they could use that sort of encrypted access to send messages securely. So it was actually designed by the US government to further espionage efforts. How about that? Okay, moving on. I'm going to check the chat, see if anybody has any comments. Any comments? Oh, we got a couple. Let's see what we got here. Microsoft, oh yeah, front page full of clickbait for sure, right? Yeah, clickbait's everywhere, right? You're always going to get some. Yeah, clickbait's inescapable. Okay, next part, indexing. So all the pages that Google has visited, right, that Google bots have visited, are stored in this internet scale database system. So Google's indexing system includes things like text, so how many times words appear, what words appear, where they're located relative to each other, what combinations happen. It includes links for images and videos, typically the metadata around them that just says what the images or videos are about. And page metadata, like what time the page was created, what times it was revised, things like that. Now, Google's main repository for all this index data is a giant tier of document servers. And the way that the index gets sorted is an important trade secret. So Google doesn't just let that special sauce out of the house for no reason. But we do know they have many thousands of servers to store all data, right? It's a whole lot of data that they have to store, and they're going to need a lot of machines available to deliver the search results quickly. Okay. So we can talk about indexing principles, though, even though we don't know all of the inner secrets of Google's operation. We talk about indexing generally. So imagine you have a library full of books and you need to find information on some particular topic. Well, you wouldn't scan every book to find matches, right? That would take forever. What you would do is build some kind of an index to help you find a much smaller set of relevant subset of relevant books. And that's basically what Google does. So for every search term, the index holds a list of all the pages containing the term, right? So for the words Chicago and the words dog and the words, I don't know, ceiling fan, Google's going to have separate index entries for all of those terms. And it sounds like a lot, sure, but it's a lot less work to build this index and then use it to find a tiny fraction of the pages than it is to try to go through Google's entire stack of web pages every time somebody does any search. So typically, if you include multiple search terms, a fairly small set of web pages are going to hold all of them. But searches for common terms, as we've seen, can easily return millions or several billion results. Okay. Google also uses something called a semantic approach to providing search results. So by semantic approach, we mean Google tries to figure out what the terms mean. And by understanding what the terms mean, it's able to find other groups of words that have a similar meaning. Okay, so all of that for Google is contained in a concept of what's called the knowledge graph. Knowledge graph is a little bit strange, but I'll just give you an example of it. Imagine if you're looking for science. Okay, so you want some information about science. Well, there are many sciences, aren't there? So we'll just go through the ABC. We go through astronomy, we go through biology, we go through chemistry. Okay, we go through physics. These are all sciences, and to an extent, any of them could potentially be interrelated, right? So surely astronomy and physics are fairly closely related. Chemistry and physics are fairly closely related, right? Likewise, biology and chemistry, pretty closely related. Okay, some of these other ones, everything is related to everything else in some sense, but yeah, in terms of what people are typically looking for, these are probably the big ones. Did I connect? I should connect that. Now, this is part of the knowledge graph. So the idea is, well, if somebody is searching for something on physics, well, there's going to be some overlap between biology and physics. You have a field called, biophysics, perhaps. And between biology and chemistry, you have biochemistry. And between astronomy and physics, you have astrophysics. So this kind of concept that if somebody turns up results about physics, they might also get results about astronomy or vice versa. It works also in the terms of people and how groups of people are linked together. So for example, for physics, we could look at astronomy and physics. So famous astronomers and likewise famous physicists, right? Now, a lot of the early names in the field are going to be the same. So you guys probably have heard of people like Galileo and Newton, right? They were also famous physicists. They're going to appear over there as well. Okay, so if you go to Google, you can start seeing stuff like this, that basically there's going to be membership that's shared across these categories. So there's going to be some overlap. And Google can help understand fundamentally. So let's do this with Google. I can do astronomers, right? It's going to give me these, no, it's not doing that today. Some of this over here, right? These are these knowledge cards here. It's going to say, here are some books. I can Google famous astronomers. There we go. I should get it at the top of them. There we go. So you get a long list of notable people, right? You get Copernicus, Kepler, all these guys. Tycho Brahe, who famously died from being unable to pee during a banquet, as I recall. Anyway, long story there. So all of these guys, Google says, oh, well, these people are all closely related. They might not be showing up in a lot of places together because you might have a lot of pages that are, say, written about Einstein or written about some of these other people, but they are all linked that they're famous astronomers. So there's some sort of correlation there. And so Google can try to use that as a baseline for saying, if somebody is searching for these things, I can show you some of these other ones. We could also do like famous people from the 1600s, right? Who are famous people from the 1600s? Newton, Bach, Vivaldi, and so on. You can find some other people. So anyway, Google is trying to use this information to basically deliver more correct search results, to try to do a better job of figuring out what people are looking for by categorizing the data in various ways. So in a sense, it's sort of like tagging the data and assigning it to different categories. But there are these common things that people look for, and Google understands some of these things are related to some of these other things. All right. So that's what the knowledge graph is. Fundamentally, it's a way that Google tries to semantically understand what people are searching for. Now, retrieval. Retrieval is no picnic, okay, because Google has this massive database. How does it search through all that and get the results quickly? Well, part of it is that Google only has to search through a small fraction of pages because of the way it's structured the index. So even though Google might have trillions and trillions of pages stored, when somebody runs a search on something, Google has already broken up that part of the index based on that subset of search terms, and it might only have to view 1 million or fewer pages. So when a search arrives, Google references the terms in its index to find the matching pages. So Google has the complete list of all pages that contain any of those search terms. Ones that tend to rank higher tend to be ones that contain all the search terms, although it's not a certain thing. For example, you do a search. Let's do a search for myself. And do Doug Lundquist UIC IDS 200. Right, see what we get there. We got some RMP, we got Course Hero, we got some Reddit stuff. Is there anything? I was hoping to find something that doesn't have stuff about me. I'm sure if I look down a little more, I'll find it. Yeah, here we go. This one, it has all the words, but they start to be broken up, right? There's a Lundquist drive and a Douglas drive. If I keep on scanning a little bit down, yeah, here we go. I start finding, here's one, it says it's about me, but it doesn't contain IDS 200, right? I can scroll down, probably find another one. You get the idea, though. You've seen this. So not every page is going to have stuff about me. Okay. Anyway, so again, like a lot of things at Google, the algorithm, the exact algorithm is a closely guarded secret, but we know the general way that it works, right? So number one, again, term and page sequence. If the terms are all present there and they're all present in the same sequence that the user has entered them in, and Google has figured out that the way the user has entered the terms correspond to typical usage, yeah, Google can recognize that a page containing all those in the proper sequence is a good match. Also, in particular, if you can find term groups with distinct meanings, right? For example, if I enter in the terms baseball team, Chicago Cubs, right? Google is sophisticated enough to understand that this is one block of terms that goes together. This is another block of terms that goes together, right? If I start doing something like team Chicago baseball Cubs, I'll get a lot of the same pages, but the results will be a little bit screwy because of the way I switched around the word order. So the word order that I entered here is going to affect the search results. So it might say, oh, out of these terms in the order that they've been written, the only thing that makes sense as a specific thing is Chicago baseball. Okay, it's going to be a little bit different. In fact, we can verify that. So if I do, let's go to Google here, I can do baseball team, Chicago Cubs. That gives me one batch of search results. Starts with the search results, official Chicago Cubs website, active roster, Chicago Cubs Wikipedia. Okay, let's do what's on this one. Then if I do what? Team Chicago baseball Cubs, right? Basically, Google's looking funny at me right off the start. It says, why are you entering the words in this order, right? But it takes a while, and it gives me a different set of results, right? So Chicago Cubs is at the top of this. I actually, here, I don't get the knowledge graph, right? I get results. Here, I get these are what are called knowledge cards. I get the list of notable Chicago Cubs players, and the sequence is a little bit different. So again, if you didn't believe it before, this proves that the sequence of search terms matters. Okay, and other stuff, again, text versus objects versus metadata, the way the text is displayed, whether it's page titles or headers, the metadata in the objects, the description of the objects. If you have a page that has a lot of pictures of Chicago Cubs players, that might show up in the listings, right? As long as they're properly tagged as pictures of Chicago Cubs players. If they're tagged just as pictures of people's names, then it's a little bit dicier. Although, again, Google is smart enough with its semantic understanding to recognize, right? So some famous Cubs player like, say, Dave Kingman, who was a big home run hitter of the 70s and early 80s for them, they would say, oh, Dave Kingman, that was a notable Cubs player, we'll include him. All right. Now, result prioritization. So, simple question. If you have many pages that all have the search terms, how should they be ordered? Okay, so once upon a time, it was pretty much entirely about the frequency of the terms, where they were located on the page, and where they were located relative to each other. So what Google figured was that a page that was saturated with a topic was a better match than one that just mentioned it, right? So for example, if you were looking for something about World War II and the page was all about World War II type stuff, that would be a better match than, say, a page that mentioned World War I, World War II, the Korean War, the Vietnam War, whatever. That, you know, World War II was one out of many wars on that page. The other thing, PageRank, right? We'll assume that sites that were larger and pages that were linked to from more places, that those would be better. Yeah, though that's what Google did. And again, for a while in the 90s, early 2000s, it worked pretty well. But the bad guys pretty quickly figured out, oh, well, we can break this and we can organize our sites to rank higher. It was basically an early form of search engine optimization. So to get around that, Google tries to do the semantic understanding, what they call things, not strings. So Google tries to understand the things themselves, not the strings, right? A string is a term in computer programming for a slug of text, right? So it's not looking at just the exact words, it tries to figure out what the words actually mean. So to do this, Google's going to try to mimic how humans search. So it's going to group text, group objects together into clusters. For example, shoe, right? Google would understand that a shoe could be represented as an image of a shoe. Typically, if somebody is making pictures of shoes, it's probably on a retail site. There's probably going to be a price associated. The way retail sites are often set up, for any given shoe, there are probably going to be drop-down menus that show the size, show the style. It's a typical way of displaying shoes. So in a sense, that would be, you know, Google would understand as that being a retail shoe, not as a shoe as an abstract concept. So if somebody goes to Google and when they search for shoes, if Google observes that a lot of people looking for shoes are looking to buy shoes, and thus they're skipping on other articles about, say, making shoes or the composition of shoes, instead they're just looking for places to buy shoes, Google is going to understand, oh, just the word shoe by itself doesn't matter. It's all these other contextual factors that lets Google understand that it's actually a retail site about shoes, and that's what it's going to prioritize in what it shows people. Okay. Other things, adaptive relevance. So over time, right, users can associate search terms with very different goals. So a couple cases, if you do a search, Google's automatically going to assume you mean very recent data. So if you search weather for your zip code, for example, Google's going to assume you want the weather now or you want some near-term forecast, right? Not that you want a long list of historical weather data going back 100 years, even though that might be the biggest site that you know, that's linked to by many places. That's where the PageRank algorithm kind of breaks down. Same thing for stock prices. If somebody searches for a stock price for a particular stock, then again, Google's going to by default assume they want the current stock price. Other times, in fairly short notice, you can have a rapidly changing meaning of what a search term will bring up. So if you search for Harvey Weinstein in late 2016, before all of his scandals broke, then you would get a whole bunch of articles about the films he was part on, probably some interviews, whatever, just fairly benign stuff. But if you searched later, you would find all of the skeevy stuff about things he did. So again, the kind of results that come up are very quickly changed on all that. And of course, you can get local variations. So hypothetically, suppose the Kardashians are appearing in Chicago for some reason, and it's a big event, then Google searches around the Chicago area for Kardashians are probably going to have that upcoming event at the top of the list, whereas West Coast Google searches, probably not. Anyway, so Google combines historical information and predictive models to give the most relevant results. So again, this is part of what it does with semantic analysis. It recognizes, people who search for weather overwhelmingly want near-term forecasts for their zip code, right? Google might recognize that, a lot of people in Chicago that are searching for Kardashians are scrolling down through the search results to find stuff on this particular event. So for that area, we're going to include it, but for other parts of the world where that's not what people are searching for, they're not going to include it. Okay, other stuff, user history. So one of Google's more recent innovations, this is within the last 10 years or so, is factoring a user's recent searches into results. So for example, you can do a what search, right? If you type in what into Google, you're going to get something like this. If I do what, I get what time is it in Chicago, because I've done Chicago stuff, okay? But if I do, let's do a completely different one. Let's do what, I've got to go to Google first. What time is the debate tonight? Yeah, that's a top one. What is my IP is always a good one. But let's go a little on. What is happening in Nigeria? I don't know. What is Ethernet? Okay, if I search and do what is Ethernet, and I find some stuff here, and let's say I click on one of them, I say, okay, Ethernet. Let's go check that out. Oh, all right, Ethernet, great. And then I do another search, and I do how does, it doesn't work on that new page. That's interesting. They keep it a little private. But if I go back and I say how does, freaky. This usually always works. All right, I'm going to go back. Let's see if it captures here. There it goes. If I do it there, I do how does. Why it didn't do it later, I don't know. Maybe it took a second for Google to update their system. Maybe there's some weird security thing on my network now that's blocking it a bit. Okay, but anyway, you can see, right, when I do how does, at that point, Google recognized, yeah, you've been looking for Ethernet, so great, we can try to find you something else on that. Okay, so again, you can try this at home to see what works and how exactly it works, but yeah, it does work. Anyway, so the algorithm is complex, it's secret, but we know a few things, right? Number one, it's supported by search history. We can independently verify that if you have one machine that you've done a couple relevant searches in a field, you'll start getting more content, more suggestions along those lines. And if you have another machine sitting right next to you, it's not going to show those same exact search results. Definitely supported by actual clicks. So once you've clicked on something in a result, then Google will say, oh yeah, this really is what you were looking for. And these rankings, they start off as global preferences, right? Google comes up with a baseline of what's topics of interest, for like what is, but it also implements how you're different. So initially, if I type in what is, I got some stuff that wasn't about the Ethernet. But after I typed in what is Ethernet, and then I did how does, then Google said, oh, well, we understand that, we can implement your individual variation to put how does Ethernet work at the top of the list. But other than that, since we don't have information on anything else, we're going to fall back on the baseline preferences. Okay, so yeah, this is implemented as Google Instant. So again, Google tries to predict how users might complete their search query based on the words that have already been typed, right? So if you do phrases like what is, who is, why does, you'll see various trending options. So interesting thing, let's try it just for giggles. Let's do who is, see who the who is. Who is Noah Cyrus? Oh shit, I don't know who Noah Cyrus is. Maybe I should. All right, there you go. I'm behind on these things. Okay, last bit. Basically how it works is essentially simple statistics, right? Google looks at popular term combinations. That's what you're going to see. And then on top of that, they're going to pile any topics that Google recognizes you're a part of. Now, this is where the semantic part of it all comes in, right? So we can say things like Ethernet, right, is equivalent to maybe something like Ethernet frames, Ethernet technology, you say Ethernet routing, any of those things, they're going to turn up a lot of the same stuff. Now, there are differences, there are subtle differences between these, but anything a person might do that falls under this Ethernet umbrella, Google's going to say, these are really close. And even if a page maybe doesn't include the term technology or include the phrase Ethernet technology, the page could still be a good match. Okay, that's the point of this semantic search. Is Google says, yeah, you know what? These terms basically mean the same thing, and they're close enough. And the basic mechanism that Google uses to learn this is essentially this. Okay, how does Google learn semantic meanings? Well, if users react to the term in largely the same way, then the terms are functionally equivalent, right? So for example, if users are equally likely to click on a page about Ethernet or Ethernet technology, Google knows they mean the same thing, right? Because how else would you tell that two things mean the same? Well, as far as Google's concerned, if, right, the two terms get the same search traffic, then they are equivalent as search results. So that's how Google learns. And to the extent that these terms have similar search traffic, Google knows the terms themselves are similar. Okay. And basically how it works against just simple statistics. There's also some filtering against defamatory and not safe for work results. So we definitely had a little thing in the news with that about Facebook and Twitter. We'd talk about that another day. But this was a thing back from 2016. So in the summer of 2016, there were a couple of things going on. One of them was the 2016 election campaign. And some stuff came up where if you tried to Google Hillary Clinton emails, right? Those of you who remember this was a thing in 2016. If you tried to Google Hillary Clinton emails, it didn't show up, right? Even if you put in all the words. So if I type in Hillary Clinton email, right? Oh, suddenly Google doesn't know how to complete that query. Well, the people on the right, they were like, see, this proves it. This proves that big tech is all about Hillary and they're covering for her. But actually, it's a more general policy. For example, if you do Donald Trump collusion, right, it can't find that N to go along with it. And the reason, again, is basically Google doesn't get sued. So the reason why Google doesn't fulfill any of these auto searches, you can still search for collusion, and you'll get search results on it, right? But it's not going to be something that shows up in the search results, again, because Google doesn't want to get sued. All right, and this concludes our lecture. So we finished it. I'm going to pop back into Blackboard here. Any questions on any of this stuff? Any points you'd like to discuss in more detail? Got a few minutes if you want. I'll stop the recording though.